Okay, so the final part of today is to calculate the errors that we had in our equipment. So throughout the titration, we've been accumulating errors. We used a mass balance to weigh out our solid, so that had an error attached to it. We then made up a solution in a volumetric flask, that had an error. The pipette that we used to pipette out had an error, and the burette also had errors to it. So these errors are all accumulative, so they add up. So what we need to do is to calculate the error for each one. So I'm going to go through that now. The mass balance, it was a digital mass balance and it weighed to 2 decimal places. So it has an error of 0.01 gram. Now I measured out 2 grams of solid. So I'm going to be looking at the error of weighing out 2 grams of solid. So I measured out 2 grams of solid. The volumetric flask has an error of plus or minus 0.15 centimetres cubed. The volumetric flask was 250 centimetres cubed in total because that's the volume we were making up. So the measure on this is 250 centimetres cubed. The pipette also has an error of plus or minus 0.06 centimetres cubed, and I measured out 25 centimetres cubed of liquid. So 25 centimetre cubed of liquid. And then the burette had errors. So every time I read from the scale, there was an error of 0.05 centimetres cubed. And I had a start reading, that was my initial reading. I had a final reading, that was my end reading. And then the final drop, so the one drop that turned it from one colour to another was also an error, and that was 0.015. So in total, the error for the burette is 0.15 centimetres cubed. From a previous calculation, I had an average titration, or an average titer of 19.83. So that error is associated with 19.83 centimetres cubed of liquid, 19.83 centimetres cubed. Okay, so now we come to the point of how do we calculate errors. So a percentage error is like any percentage. You take the error, you divide by what you measured, the range, and you multiply it by 100. So in this case, for the mass balance, the error was 0.01. I measured it over 2 grams times by 100. Okay, so that would give me an error, in this case, of 0.5%. So that's for the mass balance. The volumetric flask has an error of 0.15 over 250 centimetres cubed times 100, and that gives me an error of 0.06%. The error on the pipette is 0.06 over 25. We'll do that. So that's 0.06 over 25 times 100, and that gives me an error of 0.24%. And finally, for the titration, the error I'll just move that out of the way, I'll just move it down here, 0.15 divided by 19.83 times 100, and that works out at 0.76%. So we've got 4 errors there, percentage errors, and if we add them up, so 0.5 plus 0.06 plus 0.24 plus 0.76, we have a total percentage error of 1.56%. So that's my total percentage error for the whole of this experiment. I will use that information later.